Hello, in this lecture we'll answer on two questions. The first question we have to find out the side length of square ABCD, and in the second question we have to find out the length of line segment AD that is equal to x. So we start with the first question. In the drawing we have square ABCD. We know that the radius of the circle is equal to 2 units, and we know that line segment DE equals to 1 unit, and we want to find out the side length of square ABCD. So first of all we define the side length of square ABCD as x. So here AB equals to x according to our definition. BC also will be equal to x according to our definition. CD will be also equal to x, and AD equals to x. Okay. In the next step, I will present to you a rule that I've already mentioned in the past. It will be rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. I'll repeat again, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we define the center of this circle as point O. We define the point of tendency of tangent AD with this circle as point M. Actually, line segment OM is the radius of this circle because of the fact that line segment OM starts from point O, that is the center of the circle, and ends at point M, that is the point of the circle itself. This is exactly the definition of a radius. So we define the radius of the circle as R, and we know that R equals to 2 units. So here the radius of this circle that is OM, it is drawn to point M, that is the point of tendency of tangent AD with this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent DA will be perpendicular to the radius MO. So DA is perpendicular to MO, that is to say this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. We will define the point of tendency of tangent AB with this circle as L. Then we join points O and L together by a straight line. Actually, line segment OL is the radius of this circle because it starts from the center and ends at point L, that is the point of the circle itself. So OL is the radius of this circle, that is to say it equals to R, that is equal to 2 units, according to what is given in the question. And we have the radius OL. It is drawn to the point of tendency, that is to say it is drawn to point L, that is the point of tendency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then tangent AB will be perpendicular to the radius LO. So AB is perpendicular to LO. That is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees. Okay? And we also know that all the angles inside the square are right angles. Therefore, angle BAD of square ABCD will be equal to 90 degrees. So actually, in quadrilateral OMAL, we have 1, 2, 3 right angles. I write it down. In quadrilateral MOAL, we have 3 right angles, and the sum of 3 right angles is 3 times 90 degrees, it is 270 degrees, plus the size of the fourth angle, that is actually angle MON. In total, the sum of those 4 angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. So here we subtract 270 degrees from this equation, and we get that the missing angle MOL, is equal to 360 degrees minus 270 degrees, it is equal to 90 degrees. Okay, so I found out that the missing angle MOL is equal to 90 degrees, it is a right angle. Actually, we found out that all the angles inside quadrilateral MOAL are right angles. And any quadrilateral that has 4 right angles, it must be at least a rectangle, if not a square. So we relate to quadrilateral MOAL as rectangle because of the fact that it has 4 right angles. So quadrilateral MOAL is a rectangle. And we know that the opposite sides of a rectangle are equal to each other. That is to say, the opposite sides of rectangle MOAL, they are equal to each other. That is to say, MO equals to AL. MO equals to AL. But we already found out that MO equals to 2 units, so we can write here that MO equals to 2 units. And from this equation, 2 equals to MO equals to AL, we will derive that AL is also equals to 2 units. AL is also equals to 2 units. So we can write here that AL equals to 2 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we get that MA equals to OL. MA equals to OL. So MA equals to OL, but OL equals to 2 units according to what we already found out. It is the radius of the circle. So we can write here that OL equals to 2 units. And from this equation, MA equals to OL equals to 2, we derive that MA also equals to 2 units. MA equals to 2 units. So we can write here that MA equals to 2 units. So actually we found out that all the sides of quadrilateral MOAL, they are equal to each other, they are equal to 2 units. Therefore, quadrilateral MOAL is not a rectangle but a square. So we can write down that quadrilateral MOAL is a square. Okay? In the next step, I will present to you a new rule number 2 that I've already mentioned in the past. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. I repeat again on rule number 2. According to rule number 2, the lengths of two tangents from a common external point to a circle are equal. So here we have the common external point, point E. From the common external point E, we have two tangents to this circle. Tangent EM. And here we will define the point of tangency of line segment EB with this circle as Z. So the second tangent to this circle is tangent EZ. Okay? And actually, according to rule number 2, tangent EM must be equal to tangent EZ. Repeat again. Tangent EM must be equal to tangent EZ according to rule number 2. What is the length of tangent EM? From the drawing, it is very easy to see that the length of tangent EM it is actually equals to dA minus dE minus MA. dA minus dE minus MA. I repeat again, the length of tangent EM from the drawing it is very easy to see that it is equal to dA minus dA minus MA. So EM equals to dA. dA equals to x according to our definition minus dE. dE equals to 1 unit according to what is given us in the question minus MA. MA equals to 2 units according to what we have already found out. So actually we found out that the length of tangent EM is equal to x minus 1 minus 2. X minus 1 minus 2 is equal to x minus 3. So I write it down. EM equals to x minus 3 actually according to rule number 2 we have already found out that EM equals to EZ, but we just right now found out that EM also equals to x minus 3. And from this equation, x minus 3 equals to EM equals to EZ, we will derive that EZ is also equals to x minus 3. EZ equals to x minus 3. EZ equals to x minus 3. So we can write here that EZ equals to x minus 3. EZ equals to x minus 3, and we already found out that EM equals to to x minus 3. In the next step, we will focus on the common external point B. Okay. From the common external point B, we have two tangents to this circle. The first tangent is tangent BL, and the second tangent is tangent BZ. And according to rule number 2, the lengths of those two tangents are equal to each other. That is to say, BL equals to BZ according to rule number 2. And what is the length of tangent BL? From the drawing, it is very easy to see that the length of tangent BL is equal to BA minus LA. Again, BA minus LA equals to BL. So it is actually BA minus LA. Okay. I'll repeat again. From the drawing, it is very easy to see that BL equals to BA minus LA. So BL, the length of tangent BL, it is equal to BA. BA equals to X according to our definition, minus LA. LA equals to 2 units, according to what we have already found out. So in conclusion, we found out that BL equals to X minus 2. So you can write here that BL equals to X minus 2. But we have already found out that BL equals to BZ according to rule number 2. And according to what we have already just right now found out, BL it is also equals to X minus 2. So can I tell that BL equals to X minus 2? And from this equation X minus 2 equals to BL equals to BZ, we derive that BZ is also equals to X minus 2. BZ is also equals to X minus 2. So if I idea that BZ equals to X minus 2, in the next step we find out the length of line segment EA. What is the length of line segment EA? From the drawing, it is very easy to see that the length of line segment EA is equal to DA minus DE. Again, EA equals to DA minus DE. Okay, again, EA equals to DA minus DE. So EA equals to DA, DA equals to X according to our definition, minus DE, DE equals to 1 unit according to what is given in the question. So in conclusion, we found out that EA equals to X minus 1. Okay, EA equals to X minus 1. In the next step, I will copy triangle EAB in a new page, and we will implement the Pythagoras theorem on this right triangle, triangle EAB. Okay. We have already found out that EA equals to x minus 1, AB equals to x, so this is the right triangle EAB that I copied from the original drawing. So what is the length of the hypotenuse EB? The length of the hypotenuse EB is equal to x minus 3 plus x minus 2. Okay, the hypotenuse EB equals to x minus 3 plus x minus 2, that is to say the hypotenuse EB equals to x plus x is 2x, minus 3 plus minus 3 plus minus 2 is minus 5, so the hypotenuse EB equals to 2x minus 5 units. 2x minus 5 units. So we will implement the Pythagoras theorem in the right triangle, triangle EAB. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So actually here the hypotenuse is EB and the square of the hypotenuse is EB square. That is equal to the sum of the squares of the perpendicular, that is to say it is equal to EA square plus AB square. Okay. EB equals to 2x minus 5, so we substitute EB by 2x minus 5, and EB square equals to 2x minus 5 square, that is equal to EA square. EA equals to x minus 1, so EA square will be equal to x minus 1 square, plus AB square. AB equals to x, so AB square will be equal to x square. Okay, in conclusion, we found out that according to actually, it is, according to the Pythagoras theorem, so I will add here by PT. PT is the abbreviation for Pythagoras theorem. So actually, we found out that according to equation number 1, 2x minus 5 square equals 2x minus 1 square plus x square. Here we will open the brackets on both sides of equation number 1. According to the algebraic identity, that a minus b square equals to a square plus b square minus 2 times ab. So 2x minus 5 square equals to 2x square, that is 4x square, minus 5 square, that is 25, minus 2 times 2x is minus 4x, and minus 4x times 5 is minus 20x. That is equal to x minus 1 square. X minus 1 square equals to x square plus 1 square, that is 1, minus 2x plus x square. So in this side of equation number 1 we have 4x squared minus 20x plus 25, and on the other side of equation number 1 we have here x squared plus x squared is 2x squared minus 2x plus 1. So here we subtract 2x squared from this equation, equation number 1, so 2x squared minus 2x squared is 0, and 4x squared minus 2x squared is 2x squared. It is, and here we have minus 2x squared and minus 20x, so we'll add 2x to this equation, equation number 1, so 2x minus 2x is 0, and minus 20x plus 2x is minus 18x. So here we have 25 on this side of the equation and 1 on the other side of the equation, so we'll subtract 1 from this equation, equation number 1, and we get that 1 minus 1 is 0, and 25 minus 1 is 24. It is equal to 0. In conclusion, found out that according to equation number 1, 2x squared minus 18x plus 24 equals to 0. Here we divide this equation, equation number 1 by 2, and we get that according to equation number 1, 2x squared over 2 is x squared, minus 18x over 2 is minus 9x, plus 24 over 2 is 12. 0 over 2 is 0, so in conclusion we got the quadratic equation that x squared minus 9x plus 12 equals to 0. In this quadratic equation, the coefficient a equals to 1, the coefficient b equals to minus 9, and the coefficient c equals to 12. And the general formula to solve out the quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times a times c over 2a. Here a and b and c are the coefficients of the quadratic equation, and x is the variable that we are looking for. So here we'll put the data inside the formula in order to find out the value of the values of x in our specific quadratic equation. So here we get that x equals to minus b, b equals to minus 9, so minus b is minus 9, that is 9, plus 9, plus minus square root of b squared. B equals to minus 9, so b squared is minus 9 squared, that is 81. Minus 4 times a is 1 and c is 12, so it is minus 4 times 12 over 2a. A is 1, so 2a is 2 times 1, that is 2. So here we get that x equals to 9 plus minus square root of 81 minus 4 times 12 is minus 84 over 2. So here found out that x equals to 9 plus minus square root of 81 minus 48 is 33. So inside the root we left only with 33 over 2. So here we will have two solutions that are possible for x. The first solution for x is that x equals to 9 minus square root of 33 over 2, and 9 minus square root of 33 over 2, it is equal to 1.62. So we found out that x, according to the first solution, x equals to 1.62. X equals to 1.62. So here AB that is equal AB it is equal to x. So x is this line segment, and AL equals to 2, and you can see from the drawing that x that is equal to AB, it is absolutely greater than AL. That is to say, and we know that AL equals to 2 units. Therefore, x must be greater than 2 units because it is greater than AL. So x must be greater than 2 units. But according to the first solution for x, x equals to 1.62, that is obviously less than 2 units. So according to the first solution, x is less than 2 units, but according to what we see in the drawing, x must be greater than 2 units. Therefore, this solution is incorrect solution. We will abandon, we will cancel this solution, and we left only with the second solution for x. That x equals to 9 plus square root of 33 over 2. That is actually equals to 7.37 units. Okay, so the answer to the question is that x equals to 7.37 units. Here, that is to say, one side of square ABCD, it is equal to 7.37 units. Or in terms, or we can present it also as 9 plus square root of 33 over 2 units. Okay, so we finished with the first question. In the next step, we will answer the second question in 2 different methods. Okay. In the second question, we have here triangle ABC, line segment BD equals to 2 units, side AB equals to A units, side AC equals to 2A units, angle BAD equals to 60 degrees, and angle DAB also equals to 6, angle DAC also equals to 60 degrees. And we want to find out the length of line segment AD that is equal to x. Okay, so first of all, I'll present to you the new angle bisector theorem that I've already mentioned in the past. So what is the angle bisector theorem? According to angle bisector theorem, angle bisector theorem is true in any triangle. So here we have triangle ABC that could be any triangle. And in triangle ABC, we have here 9 segment AD that is defined as angle bisector. So why 9 segment AD is defined as angle bisector? Because of the fact that it divides angle BAC into two halves. Each half equals to theta. Okay, therefore AD is the angle bisector in triangle ABC. And actually, according to the angle bisector theorem, we get that the following equation is true, that AB over AC equals to BD over DC. I'll repeat again. According to angle bisector theorem, if we have this triangle ABC, that could be any triangle, and we have the angle bisector AD. AD is angle bisector because it divides angle BAC into two halves. Each half equals to theta. So, according to the angle bisector theorem, the following equation is true, that AB over AC equals to BD over DC. So actually, can implement rule the angle bisector theorem in our triangle ABC. Why? Because in triangle ABC we have line segment AD that is angle bisector. Why line segment AD is angle bisector? Because of the fact that it divides angle BAC into two halves. Angle BAC equals to 120 degrees, and it divides it into two halves. Each half equals to 60 degrees. Therefore, AD is the angle bisector. Therefore, we can implement the angle bisector theorem in this triangle BAC. So, and according to angle bisector theorem, we get that here AB over AC equals to BD over DC. I'll repeat again, AB over AC equals to BD over DC according to angle bisector theorem in triangle ABC. In triangle ABC, AD is the angle bisector. So AB equals to A according to what is given as the question, over AC equals to 2A according to what is given as the question. And it is equal to BD, that is 2 units, so we'll substitute BD by 2. Over DC is the missing line segment, so we leave it as it is. So according to equation number 1, we found out that A over 2A equals to 2 over DC. We have 2 in the numerator and we have 2 in the denominator, so 2 will get cancelled. And we left only, on the equation number 1, we have here, in this side of the equation, we have left only with 1 half, that is equal to 2 over DC. So here we cross multiply this equation number 1, and we get that here DC equals to 2 times 2. That is to say DC equals to 2 times 2, that is 4. We found out that DC equals to 4 units. Here, DC equals to 4 units. In the next step I will present to you the law of sines, and we will implement the law of sines in triangle AB and triangle ADC. So what is the law of sines? The law of sines is true in any triangle. So if you have, this is the law of sines. So actually if you have triangle ABC, that could be any triangle. This is triangle ABC. And we know that side AB equals to C units in its length. Side BC equals to A units in its length. And side AC equals to B units in its length. Then according to the law of sines, we'll get that A over sinus A equals to B over sinus B equals to C over sinus C. So I repeat again, in any triangle, it is true to say that A over sinus A equals to B over sinus B equals to C over sinus C. Here capital A is the angle, the size of angle BAC. This angle, capital B is the size of angle ABC, this angle, and capital C is the size of angle ACB, this angle. So A over sinus A equals to B over sinus B equals to C over sinus C. So we'll implement the law of sines in triangle ABD. In this triangle ABD. According to the law of sines, we get that here A so actually the law of sines is relevant to the second method, and in the first method we'll do another thing. In the first method, we are now in the first method, so in the first method we will do a construction. We will extend side CA by straight line. And then from point B, we will raise perpendicular to the extended CA. So this angle equals to 90 degrees according to our construction. And we will define the touching point of the perpendicular from point B and the extended CA as E. So actually here, angle BEA, this angle equals to 90 degrees according to our construction. I write it down. Angle BEA equals to 90 degrees according to our construction. Actually, CA is one side of triangle ABC, so CA is the side of a triangle, it is absolutely a straight line. And then we extended the straight line CA by a straight line and we got line segment CE. Okay, so the CE, we created CE as a result of extending the straight line CA by a straight line. And when you extend a straight line by a straight line, the result must be a straight line. So EC, that is the result of the extended of the straight line CA by a straight line, EC must be a straight line. So EC is a straight line because when you extend the straight line by a straight line, the result must be a straight line. Okay? So CE is a straight line. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So here, if we focus on the lower side of the straight line EC at point A, then the sum of the angles there must be equal to 180 degrees. So which angles we have on the lower side of the straight line EC at point A? We have here 60 degrees. And we have another angle that is equal to 60 degrees. And we have also this angle that is equal to, it is angle EAB. In total, the sum of those three angles must be equal to 180 degrees according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Here 60 degrees plus 60 degrees is 120 degrees, so we have 180 degrees plus angle EAB. In total, the sum of those two angles must be equal to 180 degrees. Here we subtract 120 degrees from this equation, and we get that angle EAB, the missing angle EAB equals to 180 degrees minus 120 degrees, it is equal to 60 degrees. So here, the missing angle EAB equals to 60 degrees. In the next step, we will focus on the right green triangle, triangle EAB. On the right green triangle, triangle EAB, we know that cosine 60 degrees it is equal to EA over BA. EA over BA. I repeat again. On the green right triangle, triangle EAB, cosine 60 degrees equals to EA over BA. So it is equal to EA over BA. BA equals to A according to what is given us the question. So we'll substitute BA by A. Cosine 60 degrees, it is equal to 1 half. So we substitute cosine 60 degrees to 1 half. And it is equal to EA over A. Here we will multiply this equation by A, and we will get that EA equals to A over 2. EA equals to A over 2. So we can write here that EA equals to A over 2. We will continue to focus on the right green triangle, triangle EAB. On the right green triangle, triangle EAB. We know that sinus 60 degrees equals to BE over BA. I'll repeat again. On the green right triangle, triangle EAB, sinus 60 degrees equals to BE over BA. So it is equal to BE over BA, but BA equals to A, so we'll substitute BA by A. Sinus 60 degrees equals to square root of 3 over 2, so we'll substitute sinus 60 degrees by square root of 3 over 2. And it is equal to PE over A. Here we'll multiply this equation by A, and we'll get that BE equals to square root of 3 over 2 times A. So we found out that BE equals to square root of 3 over 2 times A. So I tell that BE or EB equals to square root of 3 over 2 times A. In the next step, we will implement the Pythagoras theorem on the big right triangle, triangle BEC. The big right triangle, triangle BEC. So I'll copy the right triangle BEC in the new page, and we will implement the Pythagoras theorem on the right triangle BEC. Okay, so here on the right triangle, triangle BEC, we have found out that B equals to square root of 3 over 2 times A. Here EC, side EC of the right triangle BEC, it is equal to 2A plus A over 2. 2A plus A over 2 equals to 2.5A. 2.5A is 5 over 2A. Okay, so EC equals to 5 over 2A, and the hypotenuse BC, it is equal to 2 plus 4, that is 6. Okay, so this is the right triangle EBC that I copied from the original drawing. So in the right triangle, triangle EBC, by PT is the relation for Pythagoras theorem. The square of the hypotenuse equals to the sum of the squares of the perpendiculars. The hypotenuse is BC, therefore the square of the hypotenuse is BC squared. And it is equal to the sum of the squares of the perpendiculars, that is to say it is equal to EB squared plus EC square. So actually BC equals to 6 units, so BC square will be equal to 6 square, that is 36. And it is equal to EB square. EB equals to square root of 3 over 2 times A, so EB square will be equal to square root of 3 over 2A square plus EC square. EC equals to 5 halves times A, so EC square will be equal to 5 halves A square. So here we'll open the brackets on this side of equation number 2, and we'll get that according to equation number 2, (36) equals to square root of 3 over 2 A square. Square root of 3 square is 3, 2 square is 4 times A square plus 5 halves A square. 5 square is 25, 2 square is 4 times A square. So here 36 equals to 3 quarters plus 25 quarters is 28 quarters times A square. So 36, according to equation number 2, 36 equals to 28 over 4 is 7, so it is 7A square. Here we divide this equation by 7, and we'll get that according to equation number 2, A square equals to 36 over 7. We'll take out all this equation number 2, and we'll get that A equals to square root of 36 is 6 over square root of 7. Okay, A equals to 6 over square root of 7 units. So in the next step I will present to you a new rule that is actually rule number 3. According to rule number 3, if we have triangle ABC that could be any triangle, so actually this is triangle ABC. In triangle ABC we have 9 segment AD that is defined as angle bisector. And so if we have triangle ABC that could be any triangle, and in triangle ABC we have the angle bisector AD. AD is the angle bisector because of the fact that it divides angle BEC to 2 halves. Each half equals to theta. So according to rule number 3, the following equation is true, that AD squared equals to AB times AC minus BD times DC. I'll repeat again. If we have the angle ABC, that could be any triangle. We have the angle sector AD, then AD square equals to AB times AC minus BD times DC. Actually, we can implement rule number 3 in triangle ABC. Why? Because triangle ABC has the angle bisector AD. That is the reason that we can implement rule number 3 in triangle ABC. So I'll copy triangle ABC in this new page and we will implement the rule number 3 in triangle ABC. Here is the angle sector AD. So actually this is triangle ABC that I copied from the original drawing. And here AD is angle bisector, and that is the reason that we can implement rule number 3 in triangle ABC. Otherwise, we cannot implement rule number 3 in triangle ABC without the angle bisector AD. So according to rule number 3, we'll get that AD square, AD equals to X, according to what is given as the question. We'll get that AD square is equal to AB times AC minus BD times DC. Okay, AD square equals to AB times AC minus BD times DC according to rule number 3, of course. So AD equals to X, so AD square is X squared. That is equal to AB times AC. AB equals to A and AC equals to 2A minus BD equals to 2 and DC equals to 4. So if I know that X squared, according to equation number 3, X squared equals to A times 2A is 2A squared minus 2 times 4 is minus 8. So according to equation number 3, we get that X squared equals to 2 times A squared. But A squared equals to 36 over 7, according to what we have already found out. So we can substitute A squared by 36 over 7 minus 8. So here 2 times 36 is 72. And then we'll multiply minus 8 by 7 and then we'll divide it by 7 in order to have a common factor with this expression. And we'll get here that according to equation number 3, X squared equals to 72 over 7 and minus 8 times 7 is minus 56. So 72 minus 56 is 16 over 7. So in conclusion, I found out that X squared equals to 16 over 7. So here we'll take a root out of this equation, equation number 3, and we get that X equals to square root of 16, that is 4, over square root of 7. So I found out that X, the line segment that we are looking for here, AD equals to x, and it is x equals to 4 over square root of 7 units, so in terms of numbers it is equal to 1.51 units. Okay, so we finished with the first method. In the next step we'll present to you how to find out the value of line segment AD that is equal to x according to the second method. Okay. In the second method, we define angle ADB as theta. If angle ADB equals to theta, then angle ADC must be equal to 180. Degrees minus theta. So this is the second method. We defined angle ADB as theta. So if angle ADB equals to theta, then angle ADC must be equal to 180 degrees minus theta. Why? Because angle BC is one side of angle ABC, therefore it is absolutely a straight line, and we know that the sum of the angles on one side of a straight line is equal to 180 degrees. So if angle ADB equals to theta, then angle ADB must be equal to 180 degrees minus theta in order to complete the sum of the angles at point D to 180 degrees, according to the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. Therefore, angle ADB must be equal to 180 degrees minus theta. Okay? So, in the next step, I will present to you the law of sines, and we will implement the law of sines in triangles ABD and triangle ADC. So here we have triangle ABC. This is triangle ABC. That could be any triangle. Side BC equals to A units, side AC equals to C units, and side AB equals to C units, and side AC equals to B units. Then A over sinus A equals to B over sinus B equals to C over sinus C. Capital A equals to angle BAC, capital B equals to angle ABC, and capital C equals to angle ACB, this angle. And again, A over sinus A equals to B over sinus B equals to C over sinus C. We'll implement the law of sines in this triangle ABD. In triangle ABD, according to the law of sines, we get that A over sinus theta equals to 2 over sinus 60 degrees. In the next step, we will implement the law of sines in triangle ADC. In triangle ADC, here, this triangle ADC, according to the law of sines, we will get here that 2A over sinus 180 degrees minus theta equals to DC over sinus 60 degrees. Okay, 2A over sinus 180 degrees minus theta equals to DC over sinus 60 degrees. We have the trigonometric identity that sinus 180 degrees minus theta equals to sinus theta. Therefore, we can substitute sinus 180 degrees minus theta in this equation, equation number 2, by sinus theta. We'll do it now, and we'll get that according to equation number 2, 2A over sinus theta equals to DC over sinus 60 degrees. Okay, so actually, according to equation number 2, we get that 2A over sinus theta, but A over sinus theta according to equation number 2 equals to 2 over sinus 60 degrees. So we substitute that A over sinus theta by 2 over sinus 60 degrees. This is 2 according to equation number 1, and it is equal to DC over sinus 60 degrees. So here we have sinus 60 degrees on both sides of the equation, so sinus 60 degrees will get cancelled. What is left from equation number 2 after we cancel sinus 60 degrees? What is left is actually here we have 2 times 2 that is equal to DC. So actually we found out that DC equals to 2 times 2, that is 4. So DC equals to 4 units. We can write here that DC equals to 4 units. In the next step, I will present to you the law of cosines, and we will implement the law of cosines in triangle ABC. Okay. So what is the law of cosines? The law of cosines is true in any triangle So actually, if you have triangle ABC, that could be any triangle. This is triangle ABC. We know that the angle between side AB and side AC is theta. We also know that the length of side AB is equal to A units in its length, and the length of side AC equals to B units in its length, and the length of side BC is 3 units. Then according to the law of cosines, we get that cosine theta equals to A squared plus B squared minus C squared over 2 times AB. I repeat again, in triangle ABC that could be any triangle. We know that side AB equals to A units in its length, side BC equals to C units in its length, and side AB equals to B units in its length. And the angle between side AB and side AC is theta. Then cosine theta equals to A squared plus B squared minus C squared over 2 times A times B. So we can implement, the law of cosines in triangle ABC. So I'll copy triangle ABC in this new page, and we will implement the law of cosines in triangle ABC. So this is triangle ABC. We know that side AB equals to A units, side AC equals to 2A units. And here they put here BC. BC equals to 2 plus 4, that is 6. The angle between side AB and side AC is 60 degrees plus 60 degrees, that is 120 degrees. So we get that according to the law of cosines, we get that cosine 120 degrees equals to AB squared is A squared plus AC squared. AC squared is 2A squared, that is 4A squared, minus BC squared. BC equals to 6 units, therefore BC squared is 6 squared, that is 36, so it is minus 36 over 2 times AB is A times AC is 2A. Okay. So question number 3 is the implementation of the law of cosines in triangle ABC. Cosine 120 degrees, it is equal to minus 1/2, that is equal to A squared plus 4A squared is 5A squared, minus 36 over 2A times 2A. Here we have 2 on both sides of the equation, so 2 will get cancelled. In the next step, we'll multiply equation number 3 by 2A squared, and we'll get that 2A squared times minus 1 is minus 2A squared. That is equal to 5A squared minus 36. Here we will add 2A squared and also 36 simultaneously to this equation number 3. And we get that according to equation number 3, two A squared plus 5A squared is 7A squared. It is equal to 36. Here we divide this equation number 3 by 7, and we get that according to equation number 3, A squared equals to 36 over 7. Okay, A squared equals to 36 over 7. In the next step, I will present to you a new formula to calculate the area of any triangle. So if we have here triangle ABC, that could be any triangle. This is triangle ABC. And we also know that the angle between side AB and side AC is theta. And we also know that the length of side AB is equal to A units, the length of side AC is B units. Then according to the new formula, the area of this triangle, triangle ABC, it will be equal to A times B times sinus theta over 2. I repeat again. The area of this triangle, triangle ABC, it is equal to A times B times sinus theta over 2. In the drawing, it is very easy to see that the area of triangle ABC, the big triangle, it is equal to the area of triangle ABD plus the area of triangle ADC. Triangle ABC consists of two triangles, and the sum of the areas of the two small triangles, it is equal to the area of the big triangle, triangle ABC. So I'll write it down. We actually found out, according to the drawing, that the area of the big triangle, triangle ABC, is equal to the area of the small triangle, triangle ABD, plus the area of the other small triangle, triangle ADC. Okay? We'll calculate the area of triangle ABC according to the new formula. According to the new formula, the area of this triangle, triangle ABC, is equal to A times 2A times sinus 60 degrees plus 60 degrees is sinus 120 degrees over 2. I repeat again, the area of this triangle, triangle ABC according to the new formula is equal to A times 2A times sinus 120 degrees over 2. Likewise, we will calculate the area of the small triangle, triangle ABD, according to the new formula. According to the new formula, the area of the small triangle, triangle ABD, this triangle, it is equal to A times X times sinus 60 degrees over 2, plus the area of triangle ADC. The area of triangle ADC, according to the new formula, it will be equal to X times 2A times sinus 60 degrees over 2. Repeat again. The area of triangle ADC according to the new formula, it will be equal to X times 2A times sinus 60 degrees over 2. So here we have 2 on both sides of the equation. So 2 will get cancelled. We have A on both sides of the equation, so A will also get cancelled. And we know that sinus 120 degrees equals to sinus 60 degrees. Therefore, sinus 60 degrees will also get cancelled. Okay? And what is left after we cancelled all the variables here from this equation? What is left is actually here we have, in this side of the equation, we have 2A that is equal to X plus 2X. So, in conclusion, we found out that 2A equals to X plus 2X, that is to say 2A equals to X plus 2X is 3X. Here we'll divide this equation by 3 and we get that X equals to 3 over 2 times X and times A. Okay? We divide this equation by 3, so therefore X will be equal to 2 over 3 times a. X equals to, after we divide this equation by 3, we get that x equals to 2/3 times a. But we have already found out that a equals to 6 over a equals to 6 over square root of 7 units. So we'll substitute a by 6 over square root of 7 units. So here 6 over 3 is 2. So we have here 2 times 2 over square root of 7 units. In conclusion, 2 times 2 is 4 over square root of 7 units. So we actually found out that x equals to 4 over square root of 7 units, or in terms of numbers it is equal to 1.51 units. We finish with the second method. In the next step, I will summarize the lecture. We'll start with the first question. In the first question, we have square ABCD. We know that line segment, the short line segment DE equals to 1 unit. Inside the square ABCD, we have this circle, and the radius of this circle it is equal to 2 units. And we want to find out the side length of square ABCD. Okay? So first of all, we defined the side length of square ABCD as x. That is to say, DC equals to x, CB also equals to x, AB also equals to x, and DA is also equals to x according to our definition. Then I presented to you rule number 1. According to rule number 1, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. I repeat again, a tangent to a circle is perpendicular to the radius drawn to its point of tendency. So here we have the radius OM that is drawn to the point of tendency. Therefore, the tangent DA will be perpendicular to the radius MO. That is to say, this angle equals to 90 degrees, and this angle will also equal to 90 degrees. We join points O and N together by a straight line. What is the definition of line segment OL? Line segment OL starts from point O, that is the center of the circle, and L is the point on the circle itself. This is exactly the definition of a radius. So OL, it is the radius of the circle that is equal to R, that is equal to 2 units. R equals to 2 units. And we have the radius OL that is drawn to the point of tendency, that is to say, it is drawn to point L, that is the point of tendency of tangent AB with this circle. And whenever we have a radius that is drawn to the point of tendency, then the tangent AB will be perpendicular to the radius LO. So AB is perpendicular to LO, that is to say, this angle equals to 90 degrees, and this angle will be also equal to 90 degrees according to rule number 1. Okay, and we know that all 4 angles inside square ABCD are right angles. Therefore, this angle BAD, it is a right angle, that is to say, it is equal to 90 degrees. Therefore, in quadrilateral MOAL, we have 1, 2, 3 right angles. Okay. I'll repeat again, in quadrilateral MOAL, we have 3 right angles. The sum of 3 right angles is 90 degrees times 3 is 270 degrees. plus the size of the fourth angle, that is actually angle MOL. In total, the sum of those four angles must be equal to 360 degrees, according to the rule that the sum of the angles in any quadrilateral is equal to 360 degrees. Here we subtracted 270 degrees from this equation and found out that the missing angle MOL equals to 360 degrees minus 270 degrees, it is 90 degrees. So this angle equals to 90 degrees. This is a right angle. Actually, we found out that in quadrilateral MOL we have four right angles, and any quadrilateral that has four right angles must be at least a rectangle, so when we relate to quadrilateral MOL is a rectangle. And we know that the opposite sides of a rectangle are equal to each other, so in rectangle MOL, its opposite sides are equal to each other. That is to say, MO equals to AL. MO equals to AL. But we have already found out that MO equals to AL. And we have already found out that MO equals to 2 units. So we can write here that MO equals to 2 units. And from this equation 2 equals to MO equals to AL, we will derive that AL is also equals to 2 units. Here AL equals to 2 units. Likewise, according to the rule that the opposite sides of a rectangle are equal to each other, we will get that MA equals to OL. MA equals to OL, but we have already found out that OL equals to 2 units. Here, OL equals to 2 units, and from this equation 2 equals to OL equals to MA, we derive that MA is also equals to 2 units. Here, MA is also equals to 2 units, so actually we found out that all the sides of quadrilateral MOAL are equal to each other, they are all equal to 2 units, therefore quadrilateral MOAL, it is not a rectangle but a square, so quadrilateral MOAL is a square. Okay? Then I presented to you rule number 2. Rule number 2 states that the lengths of two tangents from a common external point to a circle are equal. And repeat again, the lengths of two tangents from a common external point to a circle are equal. So if we focus on the common external point E, from the common external point E, we have two tangents to this circle, tangent EM and tangent EZ. And according to rule number 2, they are equal to each other. That is to say, EM equals to EZ according to rule number 2. What is the length of tangent EM? The length, it is very easy to see that the length of this tangent EM, it is equal to DA minus DE minus MA. Again, EM equals to DA minus DE minus MA. Okay, EM equals to DA minus DE minus MA. DA equals to X according to our definition. D equals to 1 unit according to what is given as the question. We already found out that MA equals to 2. So in conclusion, we found out that the length of tangent EM equals to X minus 1 minus 2. X minus 1 minus 2 is X minus 3. So we found out that EM equals to X minus 3. So we can write here that EM equals to X minus 3. But according to rule number 2, we have already found out that EM equals to EZ. And we just right now found out that EM it is also equals to X minus 3. So from this equation X minus 3 equals to EM equals to EZ, we derive that EZ is also equals to X minus 3. Here EZ is also equals to X minus 3. Then we focus on the common external point B. From the common external point B, we have two tangents to the circle. We have tangent BL and tangent BZ. And according to rule number 2, the lengths of those two tangents must be equal to each other. So BL equals to BZ according to rule number 2. At point B, BL equals to BZ according to rule number 2. What is the length of tangent BL? From the drawing, it is very easy to see that the length of tangent BL it is equal to BA minus LA. Again, BA minus LA equals to BL. Repeat again, here BL equals to BA minus LA. BA equals to X according to our definition. We have already found out that AL equals to 2. In conclusion, we found out that BL equals to X minus 2. So we can write here that BL equals to X minus 2 from one side, but from the other side, according to rule number 2, we found out that BL equals also to BZ. So from this equation, x minus 2 equals to bl equals to bz, we derive that bz is also equals to x minus 2. Here, bz also equals to x minus 2. Then we found out the length of EA, the length of line segment EA. From the drawing, it is very easy to see that the length of line segment EA, it is equal to dA minus DE. Again, dA minus DE equals to EA. I repeat again, EA equals to dA minus DE. dA equals to x according to our definition. D equals to 1 according to what is given as the question. So in conclusion, found out that the length of line segment EA is equal to x minus 1. Okay. So I copied the right triangle EAB in a new page and implemented the Pythagoras theorem on the right triangle, triangle EAB. This is the right triangle EAB that I copied from the original drawing. We have already found out that EA equals to x minus 1. Here AB equals to x according to our definition. And the length of the hypotenuse EB equals to x minus 3 plus x minus 2. So the hypotenuse EB equals to x minus 3 plus x minus 2. X minus 3 plus x minus 2 equals to x plus x is 2x. At minus 3 plus minus 2 it is equal to minus 5. So in conclusion, found out that EB, the hypotenuse EB equals to 2x minus 5 in its length. Then we implemented the Pythagoras theorem on the right triangle, triangle EAB. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. That is to say, the hypotenuse is EB, therefore the square of the hypotenuse is EB square. It must be equal to the sum of the squares of the perpendiculars. It must be equal to AB square plus EA square. Okay, EA square plus AB square. EB equals to 2x minus 5. So EB square is 2x minus 5 squared, and it is equal to EA square. EA equals to x minus 1. So EA square is equal to x minus 1 squared. AB equals to x, so AB square is x squared. We open the brackets on both sides of the equation. 2x minus 5 squared equals to 2x squared, that is 4x squared, plus 5 squared, that is 25, minus 2 times 2x is minus 4x, and minus 4x times 5 is minus 20x. And it is equal to x minus 1 squared. X minus 1 squared equals to x squared plus 1 squared, that is 1, minus 2x plus x squared. Okay, the second x squared is from here. Okay, and so in this side of equation number 1, we have 4x squared minus 20x plus 25. And the other side of equation number 1, we have x squared plus x squared is 2x squared minus 2x plus 1. So here we subtracted 2x squared from this equation, equation number 1. 2x squared minus 2x squared is 0. And 4x squared minus 2x squared is 2x squared. Here we have minus 20x and minus 2x. So we added 2x to this equation, equation number 1, and found out that 2x minus 2x is 0, and minus 20x plus 2x is minus 18x. Here we have 25 on this side of the equation and 1 on the other side of the equation. So we subtracted 1 from this equation, equation number 1. 1 minus 1 is 0, and 25 minus 1 is 24. In conclusion, we got the equation number 1. That says that 2x squared minus 18x plus 24 equals to 0. We divided this equation, equation number 1 by 2, and we got that 2x squared over 2 is x squared, minus 18x over 2 is minus 9x, and plus 24 over 2 is plus 12. So here we have the quadratic equation that x squared minus x squared plus x squared minus 9x plus 12 equals to 0. Here the coefficient A equals to 1, the coefficient B equals to minus 9, and the coefficient C equals to 12. And the general formula for solving out any quadratic equation is x equals to minus b plus minus square root of b squared minus 4 times ac over 2a. So we put the data inside the equation and we find out the value of x, or the value of the values of x. So here x equals to minus b, b equals to minus 9, so minus b is minus 9, that is plus 9, plus minus square root of b squared. B equals to minus 9, so b squared is minus 9 squared, that is 81. Minus 4 times a is 1, times c is 12, so it is minus 4 times 12 over 2a. A is 1, so 2a is 2 times 1, that is 2. Okay? So here, so inside the root we have 4 times, minus 4 times 12, and minus 4 times 12 is minus 48. So here we got that x equals to 9 plus minus 81 minus 48 over 2. 81 minus 48 is 33, so inside the root we left only with 33. So here we have to, here x equals to 9 plus minus square root of 33 over 2. So here we have two solutions that are possible for x. The first solution for x is that x equals to 9 minus square root of 33 over 2. 9 minus square root of 33 over 2, it is equal to 1.62 units. So according to the first solution, x equals to 1.62 units. X is equals to AB, so this is x, and x equals to 1.62 according to the first solution. While AL, it is equal to 2 units according to what we have already found out. AL equals to 2 units. But from the drawing it is obvious that AL is X is longer than AL. X is longer than AL, and AL itself equals to 2. So if X is longer than AL and AL equals to 2, it means that X must be greater than 2 units. Very simple. X must be greater than 2 units. From the drawing you can see it obviously that X must be greater than 2 units. But according to the first solution, X equals to 1.62 units, that is less than 2 units. Therefore, this solution is incorrect solution. We cancel this solution and we left only with the solution that X equals to 9 plus square root of 33 over 2 units, or in terms of numbers, X equals to 7.37 units. Okay, the answer to the question is that the side length of square ABCD, it is equal to either 9 plus square root of 33 over 2 units, or we can, in terms of numbers, the side length of square ABCD, it is equal to 7.37 units. We finished with the first question. Then I presented to you 2 different methods to solve the second question. In the second question we have triangle ABC. We know that the length of line segment BD is equal to 2 units, and side AB equals to A units, side AC equals to 2A units, angle BAD equals to 60 degrees, and angle DAC also equals to 60 degrees, and we want to find out the length of line segment AD that is equal to X. Okay, so first of all, I presented to you the angle bisector theorem. Here the angle bisector theorem, it is true in any triangle. So if we have this triangle, triangle ABC, that could be any triangle. In triangle ABC, AD is the angle bisector. Why AD is angle bisector? Because of the fact that it divides angle BAC into 2 halves. Each half equals to theta. Only because we have here the angle bisector AD, we can implement here the angle bisector theorem. Otherwise, we cannot implement the angle bisector theorem without the angle bisector AD. So according to angle bisector theorem, the following equation is true, that AB over AC equals to BD over DC. Again, AB over AC equals to BD over DC. We actually implemented the angle bisector theorem in triangle ABC. Why we can implement angle bisector theorem in triangle ABC? Because of the fact that we have AD is angle bisector. Why AD is angle bisector? Because of the fact that it divides angle BAC into 2 halves. Angle BAC equals to 120 degrees, and the angle bisector AD divides it into 2 halves. Each half equals to 60 degrees. That is the reason that we can implement the angle bisector theorem in triangle ABC. And according to regular theorem, we will get that AB over AC equals to BD over DC. Again, AB over AC equals to BD over DC. So here, AB over AC equals to BD over DC. AB equals to A, AC equals to 2A, BD equals to 2, and DC is the missing line segment. We have A on the numerator and A in the denominator, so A will get cancelled. And in this side of equation number 1, we left only with 1/2, that is equal to 2 over DC. We first multiply this equation number 1, and we found out that DC equals to 2 times 2. That is to say DC equals to 2 times 2, that is 4. So we found out that this line segment DC equals to 4 units. Then we did a construction. We extended side CA of triangle ABC by a straight line, and then from point B we raised perpendicular to the extended CA. That is to say, this angle AEB equals to 90 degrees according to our construction. So we actually defined the touching point of the perpendicular from point B in the extended CA is E. So I repeat again that angle BEA, this angle equals to 90 degrees according to our construction. So actually, we extended, CA is one side of triangle ABC, therefore it is absolutely a straight line. And then we extended the straight line CA by straight line, and in this way we created line segment EC. And when you extend a straight line by straight line, the result, that is EC, must be also a straight line. That is to say, you can conclude from it that EC is a straight line. And we have the rule that the sum of the angles on one side of a straight line is equal to 180 degrees. So if we focus on the lower side of the straight line EC at point A, then the sum of the angles, according to the rule that I mentioned, must be equal to 180 degrees. So the lower side of the straight line EC at point A, which angles we have? We have here 60 degrees plus 60 degrees plus angle EAB. In total, the sum of those three angles must be equal to 180 degrees according to the rule that I mentioned. Here 60 degrees plus 60 degrees plus the size of angle EAB. In total, they must be equal to 180 degrees according to the rule that I mentioned. So 60 degrees plus 60 degrees is 120 degrees. And 180 degrees plus angle EAB equals to 180 degrees. We subtracted 120 degrees from this equation and found out that the missing angle EAB equals to 60 degrees. So this angle equals to 60 degrees. Then we focused on the right green triangle, triangle EAB. On the right green triangle, triangle EAB, it is very easy to see that cosine 60 degrees equals to EA over BA. Cosine 60 degrees equals to EA over BA. Here, in the right green triangle EAB, cosine 60 degrees equals to EA over BA. BA equals to A units, so we can substitute BA by A, and we get that cosine 60 degrees equals to EA over A. Cosine 60 degrees equals to 1/2, so we substitute cosine 60 degrees by 1/2, and we got that 1/2 equals to EA over A. We multiplied this equation by A, and we found out that EA equals to A over 2. EA equals to A over 2. This side EA equals to A over 2. We will continue to focus on the right green triangle, triangle EAB. And we know that in the right green triangle, triangle EAB, sine 60 degrees equals to BE over BA. Here, sine 60 degrees equals to BE over BA. Okay? Sine 60 degrees equals to BE over BA. So sine 60 degrees equals to BE, and BA equals to A, so we substitute BEA by A, and we get that sine 60 degrees equals to BE over A. Sine of 60 degrees equals to square root of 3 over 2, so we substitute sine of 60 degrees by square root of 3 over 2, And we found out that square root of 3 over 2 equals to BE over A. Okay, here we multiply this equation by A, and we found out that BE equals to square root of 3 over 2 times A. Yeah. BE side B equals to square root of 3 over 2 times A. Then we implemented the Pythagoras theorem on the right big triangle, triangle BEC. So I copied triangle BEC in this new page, and we implemented the Pythagoras theorem on this right big triangle, triangle BEC. What is the length of side EC? From the drawing it is very easy to see that EC equals to 2A plus A over 2. 2A plus A over 2 is 2.5A, and 2.5A equals to 5 over 2A. And we already found out that EB equals to square root of 3 over 2 times A, and the hypotenuse BC it is equal to 2 plus 4, that is 6. Okay, so implemented the Pythagoras theorem. According to the Pythagoras theorem, the square of the hypotenuse equals to the sum of the squares of the perpendiculars. So the hypotenuse is BC, so the square of the hypotenuse is BC square, and it is equal to the sum of the squares of the perpendiculars. That is to say, it is equal to BE square plus EC square. BC equals to 6, so BC square is 6 square, that is 36, and it is equal to EB square. EB equals to square root of 3 over 2 times A, so EB square equals to square root of 3 over 2 times A square, plus EC square. EC equals to 5 halves times A, so EC square equals to 5 halves times A square. We open the brackets on this side of equation number 2, and found out that according to equation number 2, 36 equals to 3 quarters A square plus 25 quarters A square. 3 quarters plus 25 quarters is 28 quarters times A square. So I found out that according to equation number 2, 36 equals to 24 quarters times A square. 28 quarters times A square. 28 over 4 is 7. So according to equation number 2, we found out that 36 equals to 7A square. We divided this equation by 7, equation number 2, and found out that A square equals to 36 over 7. Then we took out from this equation, equation number 2, and found out that A equals to square root of 36 is 6 over square root of 7. Okay? Then I presented to you rule number 3. According to rule number 3, here we have triangle ABC that could be any triangle, and we have the angle sector AD. So according to rule number 3, we get that AD square equals to AB times AC minus BD times DC. Again, AD square equals to AB times AC minus BD times DC. Implemented rule number 3 in triangle ABC, so I copied triangle ABC in this new page, and we got that the implementation of rule number 3 in triangle ABC, it means that here AD square equals to AB times AC minus BD times DC. AD square equals to AB times AC minus BD times DC. So AD equals to x, so AD square is x square, AB equals to A, AC equals to 2A, DB equals to 2, DC equals to 4, so in conclusion we found out that x square equals to A times 2A, that is 2A square, 2 times 4 is minus 2 times 4 is minus 8, so x square equals to 2A square minus 8. A square is 36 over 7, so we substituted A square by 36 over 7, and found out that x square equals to 2 times 36 over 7 minus 8. 2 times 36 is 72, and we multiplied minus 8 by 7, and then we divided by 7 in order to become factor with this expression, and actually found out that x square equals to 72 minus 8 times 7 is minus 56 over 7. So 72 minus 56 is 16. So in conclusion, we found out that x squared equals to 16 over 7. We took out of this equation number 3, and we found out that x equals to the square root of 16, that is 4, over square root of 7. So the answer to the question that line segment AD is equal to x, it is equal to either 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. Then I presented to you a second method to find out the length of line segment AD that is equal to x. According to the second method, we define angle ADB as theta, therefore angle ADC must be equal to 180 degrees minus theta. Then I presented to you the law of sines that is true in any triangle. According to the law of sines, we'll get that A over sinus A equals to B over sinus B equals to C over sinus C. We implemented the law of sines in triangle ADB. In triangle ADB, this triangle, according to the law of sines, we will get that A over sinus theta equals to 2 over sinus 60 degrees. Then we implemented the law of sines in triangle ADC. According to the law of sines in triangle ADC, 2A over sinus 180 degrees minus theta equals to DC over sinus 60 degrees. Then we have the trigonometric identity that DC, that sinus 180 degrees minus theta equals to sinus theta. Therefore, we substitute sinus 180 degrees minus theta by sinus theta in equation number 2, and we got that 2A over sinus theta equals to DC over sinus 60 degrees. Then we substituted A over sinus theta in equation number 2 by 2 over sinus 60 degrees, and we got the here that 2 times 2 over sinus 60 degrees equals to DC over sinus theta. We have over 2 times 2 over sinus 60 degrees equals to DC over sinus 60 degrees. We have sinus 60 degrees on both sides of equation number 2, so sinus 60 degrees will get cancelled. And we left only with 2 times 2, that is equal to DC. That is to say, DC equals to 4 units. Then we implemented the law of cosines in triangle ABC. What is the law of cosines? The law of cosines is true in any triangle. Here cosine theta equals to A square plus B square minus C square over 2 times AB. We implemented it in triangle ABC according to the law of cosines. In triangle ABC we will get that cosine 180 degrees equals to A square plus 2A square minus 36 over 2 times A times 2A. Cosine 180 degrees equals to minus 1 half. A square plus 4A square is 5A square minus 36 equals to 2A times 2A. We divided this equation by 2. We have 2 in both sides of the equation, so 2 will get cancelled. We multiply this equation by 2A square, and 2A square minus 1 is minus 2A square, that is equal to 5A square minus 36. We added 5A square and also 36 simultaneously to equation number 3, and we got that 7A square equals to 36. We divided this equation number 3 by 7, we found out that A square equals to 36 over 7. We took out of this equation number 3, and we found out that A equals to 6 over square root of 7 units. Okay, then I presented to you a new formula to find out the area of any triangle. According to this formula, the area of this triangle, triangle ABC, equals to A times B times sinus theta over 2. Here AC is the length of, B is the length of side AC, and A is the length of side AB. And theta is the angle between side AB and triangle AC. And we know that in this drawing, the area of triangle ABC equals to the area of triangle ABD plus the area of triangle ADC. So what is the area of triangle ABC? According to the new formula, the area of triangle ABC will be equal to A times 2A times sinus 180 degrees over 2. Okay? It is A times 2A times sinus 180 degrees over 2. The area of triangle ADB equals to A times X times sinus 60 degrees over 2. is a times x times sine 60 degrees over 2 plus the area of triangle ADC. The area of triangle ADC according to the new formula, it will be equal to x times 2a times sine of 60 degrees times sine of 60 degrees over 2. The area of triangle ADC equals to a times x times 2a, that is times sine of 60 degrees over 2. We have 2 on both sides of the equation, so 2 will get cancelled. We have a on both sides of the equation, so a also will get cancelled. And we know that sine of 120 degrees equals to sine of 60 degrees, so sine of 60 degrees also will get cancelled, and we left only with 2a, that is equal to x plus 2x. So 2a equals to x plus 2x, that is 3x. 2a equals to 3x. We divided this equation by 3 and found out that x equals to 2 over 3 times a. We substituted a by 6 over square root of 7 and found out that x equals to, here we have 6 over 3 is 2, so x equals to 2 over 2 over square root of 7 units. So in conclusion, x equals to 4 over square root of 7 units, or in terms of numbers, it is equal to 1.51 units. Okay, thank you very much.